Hi everybody, this one more video about Fourier transform of some of the standard functions or signals, that too particularly continuous time signals. This video is from Dr. A. Parimala Gandhi. So we know very well that the Fourier transform definition for a continuous time function, if the function is x of t, then it is defined as capital X of j omega. So which is integral minus infinity to plus infinity given function x of t into e power minus j omega t dt. This is the formula for finding the continuous time Fourier transform of any of the functions. Okay, now we know some of the standard signals. One among that is the unit impulse signal delta of t. Okay, so if my function is given as delta of t, you know the definition of delta of t as which is 1 when t equal to 0 and 0 when t not equal to 0, which is the mathematical expansion of this given function. Now in the definition of the Fourier transform, if we make the substitution, it will be the Fourier transform of this given function is integral minus infinity to plus infinity. Instead of x of t, we have to put delta of t into e power minus j omega t dt. Okay, we know delta of t is having unit amplitude only at t equal to 0. So even from minus infinity to plus infinity, all the values are to be assumed for t. Only at t equal to 0, this delta of t is existing. That's why we substituted only t as 0. So it becomes delta of 0 into e power minus j omega into 0. Only we put t value as 0 alone. Okay, delta of 0 is of course 1. Again e power plus 0 or minus 0, whatever is that. Anyway, it is e power 0. So that is also 1. So 1 multiplied with 1 is equal to 1. So that is the answer. And of course, it is the standard answer that for all the unit impulse functions, whether it is a continuous time function or discrete time function, the Fourier transform, Laplace transform, Z transform, all the transformations answers for the unit impulse function is always 1. Okay. Second one is for another standard function, that is unit step signal, which is denoted as u of t, and its mathematical expression for u of t is 1 where t greater than or equal to 0 and 0 when t less than 0. This is the mathematical representation of u of t. Now, if we find its Fourier transform, then it is capital X of j omega, which is integral minus infinity to plus infinity. X of t is to be substituted as u of t here into e power minus j omega t into dt. Okay, we know the meaning of u of t, where it is existing with unit amplitude only for the values of t from 0 to plus infinity. Only for positive values of t, the function is non-zero. So it is though it is substituted as u of t, in next step we can put its value as 1 in the interval 0 to infinity. Then the remaining are the same, e power minus j omega t into dt. Okay, now which is equal to, you know the integral e power ax is e power ax divided by a. So by using that formula, it becomes e power minus j omega t divided by minus j omega with the limits 0 and infinity. Okay, we have to substitute now the upper and lower limits. So if we put the upper limit, it becomes e power minus j infinity. E power minus infinity. We know e power minus infinity is 0. So it is 0 by minus j omega. Minus, with respect to lower limit, it becomes e power 0 divided by minus j omega. So this term is again becoming 0. Minus of minus will make plus. then 1 by j omega, because e power 0 is 1. Okay, which is equal to 1 by j omega. Okay, so this is the answer for u of t. This is of course a standard answer. You have to keep remembering. Okay, for the next function, when x of t is given as e power minus at into u of t, which can be taken as because of the presence of this u of t function, and we know u of t is defined as 1 when t greater than or equal to 0. So we have to make the substitution for u of t. So u of t as 1 when t greater than or equal to 0. So 1 into e power minus at becomes e power minus at in this interval t greater than or equal to 0. And 0 when t less than 0. Now its expansion is becoming as this. Okay, for this function, if we find the Fourier transform, it is as per the definition integral minus infinity to plus infinity, the given function, that is e power minus at u of t into e power minus j omega t into dt. And we got the expansion for e power minus at u of t. So put it that. So we have to consider the limit from 0 to infinity alone, because from minus infinity to 0, the function is 0. So we have to consider only from 0 to plus infinity. So e power minus at into e power minus j omega t into dt, because in this interval u of t is 1. We can combine these two terms, that is integral 0 to infinity e power minus of a plus j omega into t, because t is common term, into dt. Clear? Okay, which is equal to, we again have to apply the same formula, that is integral e power ax dx is e power ax divided by a, that is the formula. So it becomes e power minus of a plus j omega into t divided by minus of a plus j omega with the limits 0 and infinity. Again we have to substitute we have to calculate the values with respect to the upper and lower limits. So with upper limit, instead of t we have to put infinity. So it becomes e power minus of infinity, okay, divided by minus of a plus j omega, minus with lower limit it becomes e power 0 divided by minus a plus j omega. So anyway e power minus infinity will make the value as 0. Then so the first term will be 0. Then minus of minus will be plus. E power 0 is 1 divided by a plus j omega. So which is 1 by j omega plus a. That is the answer for this function. So for all the functions which are taking the form e power minus at u of t, this will be the answer. If my a value is given something like e power minus 3t into u of t, then the answer should be 1 by j omega plus 3. If instead of a we have minus 2, so that it becomes e power plus 2t into u of t, the answer should be 1 by j omega minus 2. Okay, so you should keep this in your mind, otherwise we can make the complete calculation also. Okay, so this is the answer for e power minus at into u of t, Fourier transformation of e power minus at u of t. Okay, for the next function, that is actually x of t, which is equal to e power minus a into mod t. Okay, mod t means whatever is the t value, whether it is positive or negative, always mod t will be giving positive value. So some positive value multiplied with minus a will always be e power minus of a into t alone. Okay, always e power negative value will be there for any of the t values. Okay, so this can be expanded in this way. It can be expanded as e power at when t takes negative values, that is between minus infinity and 0. We know when t takes values between minus infinity and 0, which means t is substituted with only negative values. Okay, so here if we make that substitution for negative values of t, automatically in the e power exponential power will take negative values. Clear? Here of course I have to include one more condition, that a is always greater than 0. Okay, then only it's obvious. Okay, when t is taken with positive values, that is t lies between 0 and infinity, it will be e power minus at, so that t is substituted with only positive values. So always it will be e power minus a into some positive value. Similarly here e power minus a, because of this negative t, minus at will be there. Here also for minus e power minus at will be there. Clear? But it should be taken in these two forms. Understood? Okay. Now, if we find for such function, if we find the Fourier transform, it will be integral minus infinity to 0. In the negative duration, it's defined as e power at. So, e power at into e power minus j omega t dt. Okay. Plus, in the positive interval from 0 to infinity, it is e power minus at, e power minus j omega t into dt. We know this calculation. This is the previous part's calculation only. For e power minus at u of t, this is the term we got. So it has the standard answer that 1 by a plus j omega. You can immediately write this answer for the second integration. So only we have to calculate the first integration. Okay, in this we can combine these two terms. It is in the form of e power a into e power b. So we can combine them as e power a plus b term. Okay, that is integral minus infinity to 0 e power a minus j omega into t divided by a minus j omega. Okay, that is 1 by, I am taking this 1 by a minus j omega term outside, so that after, actually here, after this integration only we got this answer. Okay, then it will be 1 by a minus j omega into, with upper limit it becomes e power 0, with lower limit it becomes e power minus infinity. We know e power minus infinity is 0, e power 1 is 1. So 1 minus 0 will be the term in this bracket. So which becomes 1 minus 0 is 1. So 1 multiplied with 1 by a minus j omega is 1 by a minus j omega. Okay, plus 1 by a plus j omega. Already we got the answer for the second part as I mentioned. So it is 1 by a plus j omega. Now take the LCM for these two terms. That is a minus j omega and a plus j omega are the two denominator terms. So if I take LCM, that is a minus j omega into a plus j omega, we have to apply the formula that a square minus b square. So whereas it is a square minus of j omega whole square. Okay. And in numerator it will be a plus j omega plus a minus j omega. So in numerator minus j omega and plus j omega will get cancelled. So a plus a will make 2a. Here in denominator, j omega whole square is the term. It can be taken as j square into omega square, where j square value is minus 1. So minus of minus 1 will make plus. That's why the answer is 2a by a square plus omega square. Clear? This is the answer for this function. E power minus a into mod t. Okay. Once if we make this interpretation, if we make this understanding, we can easily solve this problem. Clear? I hope you understand all these sums. If you are not able to follow these sums, please put in comment box so that I will give the clearance. Okay. Thank you all. Thank you for watching.